So from this video we'll be starting a new series about building scalable web applications. So what actually is a scalable web application? So a scalable web application is an application that can handle increasing amounts of load, users, data or other significant resources without experiencing a significant decrease in performance or reliability. So here the important word is significant decrease in performance or reliability. So whenever there is a sudden spike or any load is increased on a website, so you would certainly find some amount of decrease in performance or reliability. So minimizing the amount of, you could say, the performance deficit is the goal of scalable websites. Okay, so what are the challenges that occur while you are building, or factors you have to consider while building scalable web applications? Okay, so choosing between scaling up or scaling out. So basically scaling up means adding more resources to your existing computer or the web server that you're having, the cloud server. Predominantly majority of the websites today are built on VMs. Okay, so different types of like VMs, like Azure offers us VMs, and AWS is a market leader in providing all these things. So whether you're scaling up, so like adding resources to an existing, you could say, EC2 instance or any sort of a VM or a VPS system, or scaling out, so like you have a small resources, okay, small computers which are connected to each other, okay, and they transfer data and perform the applications. So like one system could be purely a web server, like it serves the web pages. Other one could be a database, or you could have multiple database engines. Okay, so like you could have a distributed database, and you could have distributed services as well in form of microservices or a purely service oriented architecture. Okay, so that is one thing you could consider. Second thing is database structuring. Okay, so how you structure your database, like we said earlier, you could have distributed databases, or you could have databases in multiple parts or shards within a single system as well. So like you could have the regularly used data in one instance, and the other data you could have in multiple other instances, or that sort of a thing. So that also you could do. So another thing is choosing the right tools. Okay, so currently we are focusing more on trends. So like many companies are adopting you could say cutting edge technologies like JavaScript based technologies or that sort of a thing. So sometimes what happens is these technologies, maybe they are not really suited well for this kind of architectures. So like when it comes to scalability, at times if your system is not designed properly, or you are choosing the wrong tools, so like if you are planning to build microservices based system and you choose something like PHP, the old school PHP, or sort of PHP based frameworks, then you would have you could say a great difficulty in integration of your services. Like it's not like you cannot do it or sort of a thing, but integration of different services and what you could say orchestration between them would be difficult. Okay, so that is one thing, important part. Then fourth thing that we have is traffic distribution. So how your traffic is going to be distributed. So like some websites have geographical hotspots, you could say. So not all websites would have geographical hotspots, but there are, like, from the location, or you could say the origination of your business, usually you would have a high volume traffic. So like servers that are close to that location should be able to handle a greater amount of traffic rather than the other servers. So like you could use proxy based solutions, or you could have load balancing solutions as well. So how your traffic is going to be distributed, so these factors also come into play when you're building scalable applications. So then what are the usual pain points in scalability? So first and the most important pain point is the wrong DBMS selection. So in the recent times, many people have tried to adopt a NoSQL solution for solutions that do not even fit in NoSQL solutions. Okay, so that is major part of this point. Okay, so like people choosing some database because it has more, you could say, they are offering some kind of hi-fi security features and sort of a thing. So people opt for those databases, but not actually understanding the domain problem it solves. Okay, so NoSQL is many times not the desired solution. So like predominantly you could do most of your things in pure SQL based databases systems like MySQL, Postgres, Oracle, DB2 and sort of things. So like Postgres is a very good option in the recent times because it has the best of the both worlds. Like you could do NoSQL parts as well and the SQL parts as well. So like that is one thing that I would consider a really great thing. Okay, so second thing is database scaling issues, like I mentioned in the previous point itself. So like database scaling issues exist. So scaling issues occur due to bad design of the database. Okay, so like bad design of the database is like you are planning to do multiple joins or you have to do multiple joins for getting a simple value or that sort of thing. So like you are making your database too, what do you call, split out or that sort of a thing, then there will be a saturation point where your queries will fail. Okay, huge longer queries will bound to fail. Okay, so make sure you are making your database properly as well as writing the queries in an optimized way. So like there are optimizer tools as well, so you could use them as well. And the third point, sorry, there's a numbering mistake over here. So third point is the abstraction layers between DB and web application. Okay, so abstraction layer between DB and web application basically is the sort of tools that are used in the modern times, as newer set of developers prefer not learning, you could say, SQL or any sort of like query languages for that matter. So they have an abstract layer or something that is called as a object relational mapping or ORM sort of a thing. So that is another thing that is a pain point when your web application is scaling, because ORMs are designed in a constricted way. Okay, so like if you're planning to do a complex operation, or if your website has a certain complex operation that needs to be done, and if you are using abstraction layer between your DB and web application, so that will be another problem which you have to face in terms of scalability. Then the fourth point is poor implementation of caching. So caching is a curious case because many people do too many things are cached or very less things are cached. So like either of the two is bad. Okay, so you need to plan your caching properly, and for that you need to first focus on what your APIs should deliver. Okay, so after you have done your pilot run of your website, okay, so you will know which APIs or endpoints get maximum number of hits. So those you could have a certain timed cache solutions, or you could have what do you call, producer consumer type of a thing in place for that caching solution. Okay, and fifth point is badly designed APIs. So this should have been the second or third point, but yeah, so badly designed APIs is yet another problem, because as I said earlier, many people tend to cramp up a lot of information into single API endpoint. So what happens is like you are delivering too much of information, so that much of your bandwidth is taken away. Okay, and when there are many requests, they pile up and queue up. Okay, so many people would face certainly a DDoS at some point of time. So that is also yet another problem. Okay, so we need to consider that as well. And finally, the too much of data being transferred in single APIs that I said earlier. So like badly designed APIs, so like you are fetching too many things at once and fetching very less things at once. Okay, so both things are bad. So like you are just fetching a simple a key or ID or a name. For that also, if you are having a different API, fetch by name, fetch by ID, and if you are having a different types of abstractions, so that is also a bad design here. Okay, so we will consider that as well. And too much of data being transferred in the single APIs, as I said, and too many background tasks running. So these days we have like different types of tasks, or you could say cron jobs and sort of a thing that are running. So those are also painful to handle. Okay, so what happens is like if your system is busy doing this background task, it is not able to handle as many requests as such. Okay, if your tasks are originating from this task, and if you are they are having some sort of you could say a mutex type of thing, where the resources that are available in a pool are not available, so that also could have issues with your scalability. Okay, and now finally, why microservices isn't the answer always. So like there's a trend, or you could say a boom into microservices. So like many organizations are transitioning into microservices, like even if they don't need it at that point of time. Okay, so like when does your application actually need microservices? So that answer is very subjective to actually what you're offering and how scalable it needs to be. Usually a vertical scaling solution is enough to solve most of the issues, but if your system is getting a heavy load, so like it is exponentially growing like at a very high rate, okay, so only then you should consider for microservices. And the major issues why microservices isn't always an option or the right answer, because rebuilding your web app from scratch in terms of microservices is an upheaval task, as I said earlier. So like dividing your whole workflow into small services, and you could say orchestrating or organizing them in a certain way is very difficult task, and it involves like multiple calls being made, and you need to time those calls as well. So like it shouldn't be like it takes like one of your services taking too much of time, then you would have a timeout at certain end. So like you need to orchestrate things properly. Okay, so that is a very difficult task. Maintenance is difficult and requires skilled professionals. So maintenance is difficult because you would require, first thing is deployment of microservices isn't a piece of cake, so you would require specialist in deployments. Okay, and apart from that you would need some kind of containerized solutions and sort of things. So you would need those professionals as well, or people who have that kind of professional competency apart from the usual developers that you're going to hire. Okay, and also one more thing you need to consider over here is that hasty solutions result in overhead costs. So like if you just plan to transition to microservices like in a very short period of time, so that is also overhead, or you could say it will result into overhead cost. The reason being, hasty solutions is like you are building something like in urgency or that sort of a thing. So what will happen is you will design a bad solution. So like your services aren't, some services at some point are failing. So like what happens is ultimately the user is having a bad user experience. So that is also important, that you shouldn't design a microsolutions based services in haste. Okay, and finally microservices need monitoring tools which also add up to the cost. So like there are many free tools like Prometheus, Grafana, so like they have the enterprise versions, but there are like the actual tools that are being used in the industry like Architect.io and stuff, so they are paid ones. Okay, so like you have an additional cost to keep this running. So like you need to monitor in real time if the any services goes down and what you're planning to do with those services. So like automatically if one service goes down, you need to make up another service. Okay, and also like services getting up and down isn't much of a problem, but if you're having databases, so like databases are breaking down like on a larger basis, and then you need to have multiple, you could say, redundant copies of your databases at place wherever you are having a high load or that sort of thing. So planning needs to be done at a very high level. So that is why we have designed this course wherein we will take into consideration different types of practical aspects of how microservices or whatever kind of solution could be deployed for making a web application scalable. Hopefully this would help. Okay, thank you.